Okay, this is going to be our first presentation. Well, presentation as in we tell you stuff. Welcome to the Game Developers Club. This presentation and demo thereafter is going to be on how you start out in the club. We're just going to give you a rundown of the tools that you use to make games and what tools are used where.
Yeah.
Okay. And without further ado, let's get into it. So, tools used in game development. There is no tool that does everything, unfortunately. Unless you count Unity, but we're not going there. So, game development requires collaboration between artists, programmers, musicians, and all sorts of fields. Because of that, you've got to use so many different tools in integration with each other. You can't just use one tool for everything. And plus, there's a lot of project management that goes on in game development. So you're constantly coordinating between this and that. So no tool does it all. No Swiss Army knife, except Unity. Okay. So first thing we're going to need, Git Clients. Does everyone know what source control is? If not, if you're kind of new, source control is the way that we share files between computers and share the changes between those files. So people can constantly work on the same project without having to upload zip file, download zip file, unzip zip file, re-upload zip file. And whenever there's two people work on the same file, there's a problem. This solves that problem and makes it a lot easier. So for Git Clients and source control, the number one recommended program is Github Desktop. That's this purple one right here. Github Desktop is just a free desktop interface that you can download from the web anytime. If you checked out that email you got right before the presentation, there should be a link for Github Desktop at the top. Another well-known one is just Git itself. This is used in the command line. You've got to learn a lot of stuff about Git in order to use it. So this is if you know how to use Git already, just use this. Honestly, just use the desktop interface. It makes it brain dead, and you don't need to know anything to use it. There's also GitLab, but that's really just Git with a different flavor on it. And there's also Perforce. Perforce is a paid version of it that you probably want to use if you're using Unreal with the blueprints. However, try to avoid using Perforce. It's not the best experience. It's kind of also expensive too. So communication tools. You're going to have to talk with your team members. Remember that. I mean, you're all online. You can't even talk in person. So you're going to have to find one way to communicate. I mean, you could use email. You could call each other. You could start a Slack conversation. Or maybe a Google Hangouts. Or best of all, Microsoft Teams. Who am I kidding? You are just going to use Discord. Screw it. Tools for art. So here's some 2D art tools. The left one that you see here is called Metabang Paint. The right one that you see here is called Clip Studio. Clip Studio is a good 2D art tool, kind of for making anime-like drawings. Metabang Paint is a free version of that. Likewise, I'm sure all of you have heard of Photoshop before. Photoshop is good for making really anything, including pixel art, 2D art, animations, I believe sometimes. You've got this, but it's outrageously expensive. GIMP, this one right here. GIMP is just a free version of that. You've also got, Microsoft Paint for those who just need to make a few dots in a circle. And Piskel. Piskel right here, you might have not heard of it before. It's an in-browser app that you'll be able to just pull it up from Google Chrome and just go ahead and make a pixel art from. It's completely free, super easy to use. It's practically like Paint, but it allows you to do all the pixel art stuff, including making animations and whatnot.
Honorable mentions, iSprite, Ace Sprite is a really good pixel art tool. And also for a lot of artists out there, there's still things like Paint Tool Sci. Those are also good Paint.
Oh yeah, Paint Tool Sci.
Yep. Okay. Paint.net.
Paint.net. Yep.
Krita.
There are so many art tools out there. It would take us all day to go through all of them. So 3D art tools. There's Blender, and then there's these other things that people talk about, but it's really just Blender. If you're going to do 3D art, you've got to know Blender. No, we're not using Paint 3D, just Blender. Okay? The one on the left is Autodesk Maya. It's basically Autodesk's version of trying to copy Blender. And the one on the right is called Meshlab. Meshlab is it's not really an artist tool. It's rather something that you can use to quickly do a transformation to a 3D model. For example, if you've got something that you did from a 3D scan, have any of you heard of a 3D scan before? If not, 3D scan is something that you can perform with a 3D scanning app that you can download on your smartphone. And basically just take a bunch of pictures of an object and will generate a 3D model for you. This one thing right here, the what's it called? Meshlab. This is Meshlab right here. Meshlab will help you quickly scale down any 3D models that you get from a 3D scan and reduce the polygon count. This is really useful because when you've got a super big 3D model and you try sticking it in Blender, all of your RAM will just get eaten up and it will not load. So music software. If you're a musician in this club and you're looking to make music for games, number one recommendation is FL Studio. Everyone uses it. Everyone's got guides for it, and it's pretty simple to use. There's also this amazing software called Renoise, which one person I should not name also uses. It's not quite like a music software. It's more like a sound sampling software.
It's a tracker.
It's a tracker. But you have the option of using it. But really just go for FL Studio. There is Reaper, which is a cheaper version of FL Studio. Ableton, which is another kind of DAW. And Cakewalk, which is kind of a free version of all this. It's a little limited in its features, though. And right here, Audacity. A lot of you might be familiar with Audacity. I do not recommend it for making music. However, when you use Audacity, it's great for doing very quick effects to sound effects and dialogue, trimming, clipping, very simple effects. Also helps you get very busted microphone noises that clip the audio. I'm not going to sample that for you right now, but okay.
I know.
So here's a native. Yeah.
Going back to music, there was one more that I know of that I just remembered exists. It's Lmms. That's sort of another one that could be used. I never used it, but I knew someone who did use it.
Is it paid?
It is free.
Free. Okay, that's a good source then.
Honorable mention, FamaTracker.
Oh yeah, FamaTracker. That's a kind of, isn't it? It's not a DAW, is it?
It's your Mega Man music maker.
Yeah, that's right. FamaTracker. I don't have that listed here. I can send out a link later if anyone's interested. Okay, and this is what probably everyone here is interested in, the game engines. This is what's actually going to be making your game logic here. The three big ones we're going to talk about in the club are Unity, Godot, and Unreal Engine 4. The others are kind of honorable mentions. Top one in the left corner is RPG Maker. RPG Maker is
Game Maker.
Sorry, Game Maker. Get them confused. Game Maker is a good 2D game making software used in games like Undertale, which you are probably familiar with already. It's a little complicated, but and it's paid, but you do get quite a reward for making something with it.
Correction, it's probably the easiest one to use.
No, compared to Godot, it's harder.
Okay, but it is easy.
Oh, fine. RPG Maker. It's not really much of a game engine, but it allows you to make an RPG, a role-playing game, really fast, without any effort. All you have to do is really just plug in the assets and use their game code, and it will make it for you. Renpi. This is this weird weeaboo one right here. Renpi is a visual novel software that has been used in games like Doki Doki Literature Club. Pretty sure you can figure out what this is going to be used for, but again, this is just a free visual novel software right here. And the three big ones, Unity, Godot, and Unreal Engine. I'll talk about this more later, but these are going to be your main ones used for game logic. they're also pretty versatile.
Just so you know, I'm not in class right now. I'm listening to something for a club.
Mm-hmm. Huh?
Keep going.
Okay. However, all of these game engines, they just pale in comparison to our almighty game engine, Microsoft PowerPoint. Anyways, so about those three game engines, Godot, Unreal, and Unity. Godot, it's very easy to start. It's open source. You can just download it online. You don't even have to install any libraries. It's only like 50 megs when you download it too. Very easy to start. Python-like syntax. You'll probably be familiar with it right off the bat as soon as you start using it. It doesn't take much effort to figure out either.
If you're in 201, CompSci 201, you probably know how to use it.
Yeah, we'll overlap with CompSci 201 if you're in that course too.
There are some things in Godot that are in Python, but it's good things about that. So yeah.
Yeah. However, Godot does have a huge disadvantage. It lacks a content library. It's a little harder to take other assets that people have made and integrate them to your game, just because it's a relatively new game engine that not a lot of people have adopted. So there's not many free models out there that you can steal. However, it is by far the easiest 2D game engine out there. It does support 3D as well, but you can just drag and drop PNGs and make them move. It's super fun. Unreal. So it's nowadays a mostly free game engine, unless you're making
over $1 million
on your game. It's free. However, Unreal's got kind of a high learning curve. It's not as easy as Godot for sure. It's a little harder than Unity.
You also want a good computer.
Yeah, you need a huge high-end spec computer if you don't want it to crash on you constantly or kind of lag. But yeah, huge learning curve, high hardware requirements. Unreal uses C++ syntax or blueprints.
If you've never used Unreal before, start out in blueprints.
Blueprints. Have you ever used Scratch before? If anyone's ever used Scratch before, this is what the blueprints are like. Though it's not going to be as easy as Scratch. But you're going to want to stick to blueprints because everyone out there uses blueprints with Unreal.
Some tutorials.
Huge disadvantage with Unreal is that you can't really use source control on it without installing Perforce, because source control on the blueprints requires source control of binary, which results in a lot of merge conflicts, which suck. So you'd have to kind of either work along with it and never have a merge conflict, or install Perforce. It's not that fun. Unreal's got a modest content library out there, so there's quite a bit of tutorials out there and a few assets that you can download and stick directly into your games. But the end result when you use Unreal is you get this beautiful looking 3D game that you can just slap on your resume and say, look, I made that. Don't do that with a default demo project though. I think someone did that in the past and got away with it.
Yeah. I mean, you can. No harm, no foul on using default demo projects.
But anyways, you'll get a beautiful 3D game when you make an Unreal Engine game. Unity. Unity is kind of like that Swiss Army knife I was talking about earlier. It can do a lot of things. It can make 2D and 3D games pretty well. You see Unity and Unreal used by a lot of the AAA companies nowadays too. Some games will be made in Unreal and they won't even tell you about it until afterwards. Unreal, of course, is made Fortnite. Epic Games made Fortnite in the Unreal Engine. Lots of games use Unity and don't even tell you about it.
Most indie games you see nowadays are in Unity.
Yeah, I can't really name any off the top of my head because they don't always mention it.
Dragalia Lost was made in Unity.
Yeah, Dragalia Lost was made in Unity.
I think Hollow Knight was made in Unity.
Hollow Knight.
Totally
I know the Pokemon trading card game online was.
Totally accurate battle simulator.
All right.
Yeah.
All right.
I feel like I remember Hat in Time mentioning Unity.
Yep.
That makes sense, yeah. A lot of things use Unity. That's because it's a versatile software. It's been out there for quite a long time. And there's a lot of stuff in their content library. Like, if you're stuck on anything, chances are someone's already made it for you and you kind of can just drag and drop into your game. Unity uses C# syntax. This is important in .NET frameworking, but you're never going to really see it too many places. However, it looks good on a resume when you say you've got.
It looks like C++, just a little more complicated.
Yeah.
But knowing it will help you very much later on in life.
Yeah, our previous game club president used this on his resume last year. Let's see. Most versatile game engine. It can make 2D and 3D games. You're going to see a lot more 3D, though, for Unity. And that's about it I've got for just describing the basic tools. Does anyone have any questions before we get into the demo? I can't look at the chat right now unless I kind of X out. Let's see. Anyone in the voice chat? Feel free to speak up if you got any questions. Is Sourcetree like GitHub Desktop? Possibly. Maybe. I've never used Sourcetree before, but GitHub Desktop is just a visual interface that you can use to control Git. It really takes no effort.
I looked up Sourcetree. It does look pretty similar. Like it's basically a user interface for Git, but just not the GitHub interface.
Okay,
like
so
it still uses Git.
So I'd say then Sourcetree and GitHub Desktop fill pretty much the same role.
Whatever's comfortable, use some type of source control.
Yeah, you do not want to be uploading and downloading zip files every time you've got a new change.
It'll be your best friend.
And that applies to everyone in your project, the artists, the musicians as well. You'll also be able to get stuff in the project so they can put it in themselves.
You don't want to just leave someone out of the source control and say, oh, you just need to send me files. Because you can make it a lot easier if the artist or musician can just drag and drop files into the game.
And they can test it themselves.
Yep.
Mm-hmm.
Okay. Any other questions before we move on? If not, let's go to the demo. So this is a list that I sent out here a little bit earlier. It should all be in your email. It was attached to the last announcement. This has links to basically every tool we just covered in the presentation just now. So what we're going to use right now is GitHub Desktop. All you have to do for that is click on the link, press the download button, and you'll get an installer. I've already ran the installer, so I'm not going to rerun it now, but it's very simple. Just accept all the defaults, accept the license agreement, and say, yes, I have read the license agreement without reading it.
Oh, my soul.
Yes, that too. The other thing we're going to use is Godot. So just click on that.
I'll go ahead and send the Word doc into the voice channel.
Good idea. So just click on that, and you'll get to the downloads page. To install Godot, you don't actually have to install anything. All you have to do is download this one zip file they give you. It's just 28 megabytes. And in that zip file is a .exe file that you can run for Godot. It's very, very lightweight. So let's see. First step we're going to do, we're going to unzip Godot and just open it up. And I clicked on the GitHub Desktop installer. If you haven't installed GitHub Desktop already, I recommend you do run the installer and set it up, because we'll need that for the next step. It will look like this, as you can imagine.
Note, some of your classes will require you to install Git on your computer. Yes, you can have Git and GitHub Desktop on your computer. And yes, I actually prefer it that way.
And once you install GitHub Desktop, it will look just like this. It will tell your repository right here, your branch right here. It will tell you a pull right here, bunch of other stuff. This is the main way how Git works. You would pull and it would download files onto your computer, and then you'd push those files. We're not going to go into the details too much right now, but for now we're just going to unzip Godot. So look, we've got Godot here. We extracted it to this folder, and to run Godot, all we have to do is double click on the exe. Pretty simple. I'll pop this open, and in Godot, it will show you all of your projects you've been working on. So, in GitHub Desktop, now we're going to do the next part. We're going to download a sample project from the Godot source repository. So, Godot demo projects, look that up. Click on the first link right here. And the cool thing about GitHub Desktop, once you have GitHub Desktop open, all you have to do is say open with GitHub Desktop. Launch GitHub Desktop, and we'll download it for you. Normally it would say clone this repository, and you'd say yes or no. This repository takes about 200 megabytes, so I've downloaded it in advance just to go on with the tutorial. Let's see. But I'll post a link to that in the Discord right now. Okay. Feel free to follow along, but it might take a little bit of time to get everything downloaded. So we downloaded the repository for Godot demo projects. All we had to do was say open with GitHub Desktop, and would open it in here and download all the files for us. If we want to update it, we can just. But that's not the point. The point that everyone wants to see is opening in the game engine and editing the game. So to do that, in Godot right here, you have to press the import button. This will import an existing game file that's been made. So what we did when we did the download in GitHub Desktop, we took all of these files in this repository right here. These files included games, such as this 2D game section, and we've got a platformer right here. So this is a Godot game folder right here. We want to open this in the Godot editor. And to do that, all we have to do is go to where our repository is. To do that really fast, you can just right-click here, show in Explorer, and now we can see where the file path is. The file path, the game I want to open up today is a platformer game. Platformer game is going to be under 2D, platformer, and it is right here. So we're going to take that file path, and when we're opening it up, we're just going to say import existing project, stick that file path in there, and import and edit. So
note, if you're starting from a blank project, you don't have to do that last step. You just open a new project in Godot.
So a little tip about game development, though. I recommend always starting from blank projects or starting from scratch. If you start from scratch, well, you're starting from scratch. You have to make all the mechanics, make all the assets. You have to make the direction of the game yourself. It takes a lot more work than stealing someone else's game, recoloring it, and remaking it, and calling it your own.
Game Dev Club does not endorse the act of stealing. All rights reserved.
Okay. But
this is being recorded, correct?
Yes.
Okay.
Let's edit that out.
Yeah. So starting from a template is always a good thing to do with a game because it gives you all of these assets you can already work with, and you don't have to really think about how the game's going to be structured because they already structured it for you. All you have to do is tweak the mechanics to what you want. So this is a game that we downloaded right here. It's a very simple platformer game. I'm making a character walk on the screen. Can you guys see it?
Yeah.
Okay. So it's a very simple platformer game. People are walking on the screen, collecting coins. I swear there used to be enemies in this. Can use a spacebar to shoot a gun. But you know what? There are the enemies. So you just shoot them with that. It's a pretty simple game. I don't even see an objective. There's like no goal flag. There's not even a coin counter. So let's fix that and make this just a little bit more interesting. First thing I'm annoyed about is that this character is extremely slow. Anyone else feel that? This is like, this is not the kind of speed for 2020. So first thing we can do is kind of fix that. So let's see. Where do you think the speed would be? I'm going around here kind of blind here, but I'm just looking at the names of things. We got game, level, player, interface, pause menu. I think it's going to be in player. So I'm going to double click on player. Player is what we call a node in Godot. A node is kind of like the basic unit that's acted on. You'll kind of find out more about it as you go with game development, but people love kind of abstracting away objects into nodes or groups or actors and all these game engines. So we're going to go into player and see if there's anything that like edits the speed. Let's see. You can still see the screen still, right? It's got some code up.
Yep.
Yeah.
Okay. So we're going to look for something, anything that relates to speed. Control F, speed. Speed. There seems to be a variable named speed. Let's see. Well, there's this variable that's called here. That doesn't seem that relevant. There's that. There's that. Huh. What it looks like, though, is that speed right here is used to determine the velocity of the character in the physics part. So, just going off a wild guess, we're just going to multiply that speed by 2. What could possibly go wrong? So we're gonna save that.
Literally everything.
Oh yeah, here we go! Whoa! Okay. This is much better. Much better. Okay. But next thing I saw is that these bullets, they're kind of lame. I mean, look, they kind of shoot and they fall. What kind of bullet is that? These aren't Mega Man bullets at all. These are like boring. So let's
like normal bullets.
No. Bullets don't fall in real life. That's stupid. If that happens in real life, that must be a bug or something. So
wait a minute.
Okay, so what we're going to do now is see if we can modify the bullet so it doesn't fall anymore. Don't know where the bullet is, so let's just look for bullet. Bullet. Right here is a file explorer right here, the file system. So it looks like there's a bullet right here. There's a bullet.png, bullet.gd, and bullet.tscn. If you don't know what this is, bullet.gd. GD is extension name for a script file in Godot, and .tscn is a name for a scene file in Godot. A scene packs a bunch of resources together. A GD script is basically the underlying code. Let's see what happens when you open up the bullet scene. So when you go to the bullet scene, it looks like there's really there's something there. There's this little dot. Oh, look, there's a little image of a bullet right there. Isn't that cute? So we want to modify this thing so it doesn't fall. What's right here? And it's got a script on it. But there's no like physics stuff in the script. There's just like kind of boring stuff. Destroy, on body entered. That's kind of lame. I'm gonna cheat here a little bit, but we know that right here, this is called a rigid body 2D. With a little bit of background in the Godot editor, I know a rigid body 2D is a body that is controlled by the physics engine, as described right in this box right here. A body that's controlled by the 2D physics engine. But the thing is, we don't want it controlled by the physics engine. We want it to just kind of go infinitely forward. So to do that, we just need to do one thing. Change this from a rigid body 2D to something else. Let's do that. Let's say right-click on it, change type. Let's try changing to a node 2D. A node 2D in Godot is the basic node that in 2D that does nothing but stays there. It can stick other objects in it, but it's just something in 2D to stick other objects into. So we're changing it to node 2D. And that causes a slight problem because there's this little exclamation mark on collision shape 2D. And says that this only serves to provide a collision shape to a collision object 2D derived node, blah, 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 blah. Which is lame. It seems like if we do this, our bullets aren't going to hit anything. Let's try that. Let's see what happens when we run this horrible mess of a game. Oh, looks like we're getting an error. Okay. So script inherits from a rigid body 2D, which we just changed it from, and it can't be instanced from a object of type node 2D. Okay, so we couldn't change it to a node 2D. Let's try changing it to something else. First, let's edit the script so it stops extending it from a rigid body 2D. Let's try doing a node 2D. Just force our way on the game. Press the play button, see if it works now. Oh, linear velocity. Darn. It looks like a rigid body 2D has other properties like linear velocity, which a node 2D normally would not. So let's go back to the bullet and let's change it to something maybe similar to a rigid body 2D. What could be similar to a rigid body 2D? So looking at the things with the name body 2D, we've got rigid body 2D, a body that's controlled by the 2D physics engine, static body 2D, static body for 2D physics, and kinematic body 2D. Let's try a kinematic body 2D. That seems similar enough, right? So surely if we just change this to kinematic body 2D, it will work, right? Huh? It looks like linear velocity isn't on kinematic body 2D either. Okay. Looks like we've got to change our method around. Instead of finding something that has linear velocity, let's force it to have a linear velocity. What could go wrong? Okay. So let's go back to this kinematic body 2D that we've got now. It looks like this doesn't have a linear velocity, but it needed a linear velocity when it gave us that error. Let's go back to the error. Linear velocity. Bullet.linear velocity. Okay. So let's go back to the bullet and we look right here. There's something that says var this equals that. Well, if I don't know too much Godot and I don't know what I'm doing at all, I know the name var sounds a lot like variable. So I'm just going to copy and paste that line and say, we want a variable named linear velocity. And let's set it to 0. Aha. Now we've got a linear velocity. Let's see what happens now. Oh, look, we got a bullet. It kind of just stays there. That's kind of cool. It's maybe I can't jump over it. Actually, I can kind of jump on it. That's funny. This might not be quite what I want, but we're getting closer. We're customizing the bullet. So it doesn't even kill the enemies. Okay. So we do have a bullet now that obeys some of our physics principles. But we need a move, right? So let's see. What can I do with linear velocity that will, actually do something? So I'm gonna, instead of using an amount like 0, I'm gonna call it vector, like vector to 0, 0. I kind of cheated there, but a vector 2 is kind of something used across a lot of game engines, including Roblox, believe it or not. This indicates a direction. So like the direction of the bullet would be this amount in the X direction, this amount in the Y direction. So we've got a linear velocity, we've got a direction it's going in, but how do we move it? Let's see. So when we went back to the gun, it seemed to change the linear velocity to be a certain amount. That's cool, but how do we move it? Let's see if there's like anything that relates to physics in this engine. No script, no. Let's go back to the game and see how the player moved. Huh? Looks like there's this thing called physics process that we were originally editing. And wait, when we changed to speed, it said calculate move velocity. Huh. And move and slide on floor with snap. Huh. Surely those wouldn't be important, would they? Probably not. Let's just cheat it. Funk. Physics process. That's the same function that was in the game. Okay. It just auto-corrected it for me. Let me go to that. Physics process. And let's see. I know since I'm working with a bullet, it looks like it's got a position. That's cool. Position can be found right here. So what if we made that velocity update the position? Then we've got some stuff to do. So position equals, well, I know I've got to use the linear velocity, right? What do you think I could do to make the position update with linear velocity? Any takers? Anyone? Anyone?
I know the answer.
You want to say it?
Yeah,
You don't know?
I do. You gotta add it.
Mm-hmm.
Yeah. To the
To position.
That's right.
That might cause a little bit of problem, but let's see what happens.
Ah,
The answer is 42.
Can't you just plus equals linear velocity?
So it looks like when we shoot the bullet, it's there for a brief second,
oh god.
but then it seems to kind of just disappear.
Oh god.
I think we might have just shot the bullet into outer space. Okay, let's see. Maybe we can scale it down a little. So we've got delta, the amount of time between bullet A being in here to there, position, the original position of the bullet, and linear velocity, the velocity of the bullet. Let's see what happens now. Oh, there we go. Oh, look at that! Look at that! The bullets just go. Oh, cool! Look, I've got a bunch of bullets that can just go through everything. What if I try those stupid bugs? Oh, looks like they're not dying. I wonder why. Did we possibly do something to the bullet? Huh. Surely there must be something we can do. So we know that here's a bullet. It moves on its own. If I just like move it around. Woo! So that's what happens. That's what's happening here. But we've still got a problem. It's moving around, but it's not hitting the enemies. Why could that be? So let's go look at the kinematic body that we had in the first place. Kinematic body with like rigid body. It must be something to do with it. Physics body 2D. Collision. Mass. Oh. Could this be something to do with the collision? Layer mask. Maybe we messed that up when you changed it to a node 2D. Let's let's like undo everything. So we've got it as a rigid body. Look at that. The mask setting was different. It had these buttons, no layer. Let's change it. Let's redo our changes. Change this back to a kinematic body 2D. And let's go back to the mask. Oh, looks like when we changed it directly, it kept the mask. So we've got the right mask now. In case anyone's wondering what a mask is, a mask pretty much tells you what I'm going to hit. So the enemies are on a layer of collision physics. They're not going to be just there. They're going to be on like layer 1, layer 2, layer 3, layer 4. The reason why we've got a bunch of layers is because sometimes we don't want object A to collide with object B. To do that, we say that object A is on this layer and object B is on that layer. However, sometimes we still want some things to collide that aren't on the same layer. They tell us we're going to check for layer, but we're really on that layer. So this is on no layer. It's not colliding with anything of itself. Well, looks like we've got the mask all set. So let's hit the play button again. Just need a kind of moon jump up to the enemies. Oh, looks like it's hitting them. What the heck? I think that's good enough. We're just kind of bullying them. Not sure what happens to the lethality of the... Oh! Oh, boy.
Hey, that was more fun than the original.
Improvement. But you know what? I think we can do more. We need to make bigger guns with more firepower. I mean, currently the way we have, it's kind of boring. We just... You hear that space bar? We can do better. We need, like, auto fire. So let's make that happen. Let's see. So let's go back to the game scene. What possibly could be controlling how the person fires? The game? No. The level? Maybe. Player? Probably. So let's go back into the player and go back into that script. I wonder if there's anything that mentions gun or bullet. Bullet, 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 bullet. That's boring. Gun. Without gun. Gun, shoot. Ooh, that's kind of what we want, right? Gun, shoot. We just want it to shoot as many times as possible. So it says if action is just pressed. Come on. So that means like if I just press it once and don't release it, it shoots? You know what? I don't like that word. We're going to take it out. We're going to say if action is pressed. Okay. See what happens now. Nothing can go wrong. Oh, yeah. Yes. This is the best thing ever. Okay, so now we've got our auto fire. We've got bullets going through walls like Mega Man. What else do we need? Let's put more bullets in. Right? So let's go back to here. Go back to the game. So the players seem to have a gun. So let's go back to the player. Is there a gun here? Oh, gun. We've got a gun. Looks like the gun's got just kind of like there in front of the player. Let's make multiple guns. Let's, copy, paste. Where's the copy button? You know what? I'm going to use something else. I'm going to say duplicate. Yeah, that's it. Duplicate. Yeah, there we go. So now we've got multiple guns. Let's just move them around a little bit. Woo! Woo! Okay, now we've got a whole wall of guns going here. So looks like we have that gun. That gun is addressed by this thing that says sprite git node gun. Well, it looks like when we copied it, we had gun, Now gun 2, gun 3. Looks like we need more guns. So let's just copy this line and change it to gun 2, gun 3, and also change the variable names. Go back to the original gun and make those also shoot. So just copy this line. Okay, now we got gun shoot, gun 2 shoot, gun 3 shoot. Oh yes! Yes. Okay, so we've got 3 guns, we've got rapid fire, we've got bullets that clips through walls. What else could we say that we need here? Any ideas? Any ideas here? What
The
else?
ability to go through walls.
What did you say?
Just straight up like fly God mode.
Fly, God mode? I'm not sure how possible that is, but let's see. So, flying. Let's see, we've got a player and a script on that player. I think that would be controlled by how the player moves, right? I've got an idea. Let's just remove gravity. Gravity. Darn it, no gravity.
And collisions.
Gravity. Where is the gravity? So move. Move and slide. Down, down. Can't find the gravity. There's nothing labeled gravity. Where could the gravity be? Maybe it's somewhere else. Maybe it's in the player. No? No? Maybe it's in the level. No, maybe? No? Maybe it's in the game. Gravity. No. Let's go back to the root of it. So it moves with this calculate move velocity, right? Direction, gravity, velocity, velocity. Oh wait, it should be using the velocity. Velocity, direction, is jump interrupted.
Calculate move velocity.
Yeah, but where's the gravity? Maybe it's the direction. Get direction. What's get direction? Huh. That just controls player movement. So let's calculate move direct. Oh, looks like velocity times y minus 6. Let's edit that. I don't like that. There we go. Let's not edit that. So I can't find the gravity at the time, and it looks like we're just out of time. So I'm gonna just do one quick edit. I'm gonna go back to the player, and let's make the bullets like colored. Right? So we got gun, gun. So we got gun this, gun that. Now let's just color the player. You know, what every OC needs is a recoloring. So we're gonna take this, modulate. That sounds like a cool property. Let's make him red. Yes, now we've got our Terminator. Just outright killing everything. Okay. Okay, I think that about does it for the tutorial. I'm going to post a recording of this online a bit later. Any questions? By the way, this tutorial wasn't done to show you how to make a full game, but really just show you how to take any free template out there, just screw around with it, and you get something completely different. That's why I don't recommend building games from scratch. It's way more fun to just take something someone else made and make it into your own. Okay. If there's any other questions, I'll be here on to answer them. Otherwise, have a nice day.